Hi, welcome to BIO1026, Chemistry of Life. Today we are in lecture 6 and we will talk about Aldol and Claisen condensation. Okay, basically these two reactions are a carbon-carbon bond formation reactions. The aldol basically is a reaction between a ketone or an aldehyde with himself, okay, where R1 could be an alkyl group or a hydrogen to form this kind of compounds. Okay? Basically, we will recognize when we are doing an aldol because the end product has a 1 carbonyl free hydroxy compound. Sometimes we can have an elimination, and what we will get is the alpha beta unsaturated product. Okay? This is depending on the reaction conditions. This reaction can be done in acid media or in basic media. We will start with the basic media conditions. In basic media, basically what we have, we start with our molecule, okay, and we add a base. The base could be sodium hydroxide, is the most common. What will happen is that, remember, this hydrogen in the alpha position, 1 carbon away of the carbonyl group, this hydrogen is quite acidic. Okay? A base can take it, and what we get is the anion in the alpha position, or we can do the resonant form. This is because this is the reason why it's acidic. We can get the resonant form. Okay? What I recommend is that use this resonant form where the negative charge is on the carbon. Why? Because it's easy to check what is happening later if we have the anion here. Then this is reacting with another molecule of the aldehyde or ketone. This is a nucleophile, it's a negative charge. Remember that this is a carbonyl group. That means that this bond is polarized. We have a density positive charge on the carbon and a density negative charge on the oxygen. That means that this carbon is electrophilic. The negative charge will attack here. The pair of electrons that are forming the carbon double bond oxygen are going to the oxygen, and we form this carbon-carbon bond, carbon-carbon bond. We get this product that can be protonated to generate the final aldol product. Okay? If we are in basic media, this compound could, not always, I will indicate if I want to do dehydrate or not, could do a dehydration. Okay, basically, we are in basic media, we have alcohol as a leaving group, and we have electron with driving group in the alpha position of the hydrogen that we will eliminate. That means this will be I1Cb. please check the notes of lesson 2. Basically what will happen is that the base will take this proton, we will form the ion, and then after a while the OH will be leaving. This is the only way that OH is a good leaving group in a E1CB, and what we will get is this final compound. Okay? Check that in this type of compounds, when we are doing the dehydration, okay, always we get the double bond conjugated to the carbonyl compound. Why? Because this is more stable than not if it's not conjugated. Okay? This is the Aldol reaction in basic media. But I told you that also can be done in acid media. Okay. How is in acid media? Well, we start with the same starting material, okay, but now we have acids. The first thing is that this, when we are in acid media, you know that we have the equilibrium keto-enol. Basically what we will have is the enol form, okay? This enol form will react. This is the same as this, it's only the other tautomer, will react with the protonated form of the carbonyl group. Remember, if we have acid in the media, normally what we do is the protonation, okay, and then we are reacting this plus this form. Why? This is less nucleophile than not the enolate. If we remove this proton, this obviously is more nucleophile. This is a weak nucleophile. For this reason, we are using a strong electrophile. Remember that when we protonate this carbonyl group, what we are doing is increasing the electrophilia of this carbon. Okay, this carbon becomes more electrophilic, and then even a bad nucleophile like enol can react with this compound. What we get this compound that after losing one proton, we lose this proton, we get the final aldol product, the 1-carbonyl free hydroxyl compound. Okay? Basically we get the same that in basic conditions, but now what we are doing, the nucleophile is the enol, and the electrophile is the protonated form of the ketone or aldehyde. And as I told you before, this can eliminate. How? Well, we are in acid media. Obviously we cannot eliminate with E1CB, because in a E1CB elimination what we need is a base. We have protons. What we will do is a E1 elimination. We have this, we protonate the alcohol. Now it's a very good leaving group. The OH is leaving, okay? We form a carbocation and then check the lecture number 2. this hydrogen is leaving and we form the double bond. Again, the double bond that we are forming always is the conjugated one. Okay? Always is the conjugated one, where the double bond is conjugated to the carbonyl group. Okay? These are the Aldol reaction in acid media and in basic media. Can be done the Aldol reaction with two different carbonyl groups? Yes, but this will be seen in the next lecture. Okay, now it's better that we understand how it's working the Aldol, and in the next lecture we will complicate it a little bit, the procedure. Okay? But now remember that we have the Aldol reaction that is forming, this is the most important, the 1, 2, 3, one carbonyl free hydroxy compound, the aldol ion that this can eliminate or not. Okay, and then how it's working in acid media and in basic media. In basic media, we form the enolate, is attacking the ketone or the aldehyde, forming the one carbonyl free hydroxy compound, and then elimination, and because we are in basic media, has to be E1CB. In the case of the acid media, what we do is A1 elimination. We protonate the alcohol to make water that is a very good leaving group, and then we have the elimination. Okay? Good. Now we will talk about the Claisen reaction. What is the Claisen reaction? The Claisen reaction is basically the reaction between two carboxylic esters. It's very similar to the aldol, but in the aldol we are using two carbonyl compounds, ketone or aldehyde. Here what we are using is an ester. The Claisen reaction always happens in basic media, cannot be done in acid media. And how it starts? Well, we have here the ester. Okay. And the first step, we add a base. And basically, remember that the hydrogen in alpha position to a carbonyl or carboxyl compound is quite acidic. That means that the starting reaction will be very similar to the Aldol reaction. What we have is the formation of the anion. When we have this anion, this is reacting with another molecule of the ester. Okay? Remember that we have a carboxylic group, but basically this is very similar to a carbonylic group. This is a polarized double bond. We have a density positive charge over the carbon, a density negative charge over the oxygen. That means that this position, this carbon is electrophile. That means that the nucleophile, the enolate that we form, will attack the carboxylic compound. And remember from lesson 5 that the carboxyl, when we attack a carboxyl group, what we are doing is an addition. We generate the tetrahedral intermediate. we generate the tetrahedromer intermediate, and then we do an elimination. Addition, tetrahedral intermediate, elimination. We regenerate the double bond, and the leaving group, in this case the top side, is leaving, and we generate this final compound. Check that the characteristic of the Claisen reaction is that we get one carboxyl free carbonyl compound. 1, 2, 3. Carbon 1 we have a carboxylic, an ester, and in the third position we have a carbonyl group. This is the end of the reaction? No. Why not? Because remember that what we generate is a alkoxide. Alkoxide is a scrum base, isn't it? And we have this proton here that is very acidic. Why is very acidic, this proton? Because he is alpha to 2 carbonyl compounds. That means that the top side will take this proton, and the final product of the Claisen condensation, if we don't do anything else, is the anion. Why is important? Because basically all the reactions that are in the Claisen condensation, all the steps are reversible except this last step. If we are not able to deprotonate the final compound, the reaction will not take place. Okay, for example, I will put we can use this ester. Imagine that we use this ester. Okay? We add a base. We take this proton, we generate an ion. Remember that if you want, you can put the other resonance structure. It's up to you. I recommend to keep it in the carbon, the negative charge. And then this is reacting with another molecule of the ester. Okay? I do the same, exactly the same mechanisms, addition, and then simply I take place elimination, I regenerate the double bond, and what we get is this compound. Okay? This is the final compound, plus ethoxide. Now, we can remove the proton? No, because simply in this position, in the position in the middle of the 2 carbonyl groups, we don't have any proton. We have 2 methyls. That means the deprotonation doesn't take place. If this happens, the reaction didn't work. we will have a horrible mixture of all the possible products. Okay, the reaction is not working well. Right? This is the difference. We need to deprotonate the position in the middle in order to get the final product. If not, it will not work. This Claisen reaction also can be done intramolecularly. Okay, we will put an example of intramolecular Claisen reaction. For example, this. Okay, how it's working? Basically the same than before. We at a base, we remove one of the hydrogens. In this case, it's exactly the same. Which hydrogen we will take because are symmetrical. And what we do is we form an ion, and then, as we did before, attacks, in this case intramolecularly, because we have the ester in the same molecule. Addition, remember always addition. Addition, we regenerate the double bond carbon oxygen, and the leaving group is departing. We generate this plus ethoxide, and then the ethoxide is taking this hydrogen to get the final compound of the Claisen. If we want to get the protonated, what we need to add is hydrochloric acid aqueous, and what we get is the final compound protonated. Okay? But this is a second step. Okay, this is the Claisen condensation. Both are very important in biology. Check the lecture notes where I explain the importance of these reactions in biology. And that's all what I want to explain about the mechanisms and the chemistry of the Aldol and Claisen reaction. Remember that we will do more Aldol reactions in the next lesson, a little bit more complicated, but this is what we do in this lesson. Thank you for your attention, and see you soon.